Good day, students, scholars, and curious viewers. This is Mr. SKT, or otherwise known as the Super Kuroishi teacher. In today's video, we're going to be doing type 3, unofficially, of the algebraic equations known as the both sides. I call them both sides because they literally have variables on both sides. So an example of this one is 3x plus 10 equals 2x plus 20. And you are required to solve for x. Solve for 1x. So to do this, it's pretty simple. All you have to do is unite all the variables on one side and put all the numbers on the other side. So what I'm going to do in this case is I'm going to take this 2x and I'm going to bring it to the left to be with the 3x. And this 10 over here, I'm going to bring it to the right hand side so it can be with the 20. What happens here is that on the left side you have 3x. You start with the 3x because it was there first. Then the 2x, remember, anything that crosses that equal sign becomes its opposite. So what was 2x before, when it crosses the border, the equal sign, it becomes minus 2x. And that equals, there was a 20 over there, and then the plus 10 on the left becomes its opposite, which is minus 10. So here, now you've got the variables on one side, and you got the numbers on the other side. You can now simplify them. 3x minus 2x gives you 1x, and 20 minus 10 gives you 10. Thus giving you a final answer, x equals 10, problem solved. And that's basically what you need. That's the basics and the general rule of what you are expected to do with any kind of equation where the variables are on either side of the equal sign. Now, of course, this was just the most basic example I could think of. There are other ways in which they will try to trick you, other ways that they will test the skills that you will have simulated before doing these kinds of algebraic equations. So let me show you a few other examples. So example number 2, I'm going to try something like this. I'm going to introduce some brackets into the mix. So here I've got a situation where I've got 2 into x plus 5, and that equals 4 into x minus 9. So step 1 is to get rid of those brackets. Those brackets are getting in the way. So using the distributive law, because you have a number multiplying into a bracket, do it for both sides. So you end up with 2 times x, which is 2x, plus 2 times 10, which is 2 times 5, which is 10, equals 4 times x, which is 4x, and minus 4 times 9, which is 36. Now, from there begins the debate. Do you bring the 4x onto this side and thus taking the 10 over there? Or do you bring the 2x onto that side and put the negative 36 over there? The answer, it doesn't matter. As long as you put the variables on one side and then you put the numbers on the other. And just to show you, I'm going to do this one both ways. So the first way is I'm going to bring them to the left hand side, and on the other way I'm going to show you what happens if I bring the variables on the right hand side. So 2x plus 10 equals 4x minus 36. And I'm going to show you This is what happens if you bring it on the left-hand side. So bringing the 4x over there, which means the 10 is going to go over there. So that's going to be 2x. Why 2x first? Because the 2x was already there. The 4x is now moving in, so it comes afterwards. That was positive 4x before. When it goes over the equal sign, it becomes its opposite, thus becoming negative 4x. And that's going to equal negative 36. And that 10 over there, that positive 10 is going to become a negative 10. So you end up with 2x minus 4x. So 2 minus 4 giving you negative 2x. And that's going to equal negative 36 minus 10, which is negative 46. And thus, x equals, take that negative 2 over to the other side. That was multiplying. So that means you're going to divide on the other side. So x equals negative 46 divided by negative 2, which means x equals 23. Okay? Now, let's see what happens if we instead put the variables on the right-hand side. So, we're going to start off like the other side, which is 2x plus 10 equals 4x minus 36. And instead, I'm going to bring the 2x over this side. And that means I'm going to have to bring the negative 36 over on the left side. So which means the left side is going to have 10, and that negative 36 is going to become a plus 36. And on the right side, there was 4x there, and that 2x becomes minus 2x. So I end up with 10 plus 36, which is 46. And that equals 4 minus 2x, which is 2x. In case you're wondering why I don't have to have it on the left-hand side, because even though for the past two types of equations, we've been keeping things on the left-hand side. In reality, I've been keeping it on the left-hand side because it sounds like a more coherent number sentence. It sounds more like you're saying x equals instead of this number equals x. But in reality, it doesn't matter which side x is because you are still answering the question. You are still solving the value for x. The only difference between here is the signs that you are working with. Sometimes you may feel that, hey, you notice that it will remain positive on the right-hand side, but then it will be on the right-hand side. Or sometimes you may feel you're used to having it on the left-hand side will be negative. But here, I am showing you that it does not matter what side it's on, because in the end, you are going to get the same answer for x. X equals 23. So this is my way of showing you that the main thing with algebraic expressions, especially when it comes to both sides, is that you need to move the variables onto one side and then keep the numbers on the other. And it doesn't matter whether it's the left or the right. The main thing you have to take note of is your signs. You have to make sure what was already there, it keeps its sign, and what is moving has to change its sign. Right. I hope that makes it understandable. Let me do one more example with you before I give you today's exercise. Let's do something let's try this out. Let's go 4x squared plus 20, and that equals 5x squared 5x squared, and that's going to minus 60 minus 60. Yes, I believe that works. All right, let's do this. 4x squared plus 20 equals 5x squared minus 16. Right, so you need the variables on one side and you need the numbers on the other. Yes, so we are dealing with x squared and x squared. They are the same base, so like terms will work. At grade 8 level, you don't work with x squares and x's in the same thing. That comes more grade 9 level when you do things like factorization. But at this stage, you just need to focus on like keeping like terms together. So like I said with the previous one, you can have it on whatever side you want. I prefer going on the left side because I'm kind of used to it, and also because I'm left-handed. So what I prefer is bringing the 5x squared on that side, which means I would put the 20 on the other side. Like I said, if you want to bring the 4x squared on the other side and push the 16 onto the left, you can do so. It should give you the same answer. Anyway, so I would then end up with 4x squared. That 5x squared is going to turn into a negative 5x squared, and that's going to equal negative 16. Positive 20 is going to turn into a minus 20. 4x squared minus 5x squared gives you 4 minus 5, which is minus 1. So minus 1x squared equals negative 16 minus 20, which gives you negative 36. And remember, we have to work out what x squared is. So they're both minuses. You can just technically cancel the minuses because you can divide them both by minus 1. So cancel the minuses. You'll end up with x squared equals 36. Move the square sign over and you get the plus minus square root. So x equals plus minus the square root of 36, which equals plus minus 6. And there we go. All right. Now let's prepare for your exercise. All right. After a short break, I'm back with your exercise. So, as you see, students, this is the exercise that I set up for you. The main instruction is to solve for the unknown. So with that being said, if you like to do this by yourselves, then please pause the video in 3, 2, 1. Okay, with that being said, let's do the correction. Alright, so the first one, we had 5x plus 20 equals 3x minus 30. Like I said, you can have the variables on the left or the right. It's what matters to you. As long as you make sure that whatever you have on one side, if you have the variables on one side, you have the numbers on the other side. I prefer having the variables on the left. That's just how I like to do things. If you like them on the right, then make sure you have the numbers on the left. It's straightforward like that. But anyway, so I'm putting my 3x on the left hand side, which means I will be bringing the 20 on the right. The 3x will then turn into a minus 3x, and the 20 will turn into a negative 20. So 5x minus 3x gives me 2x, and negative 30 minus 20 will give me negative 50. That's 2x, by the way, so that means 1x, take the 2 over the other side, will be division by 2. That means x will equal negative 50 divided by 2, giving me negative 25. I brought a lot more negatives and fractions into this exercise. By the way, I was actually quite surprised. Alright, next one, we got negative 2y minus 5 equals 5y minus 16. I brought the 5y over to the other side. That means I brought the negative 5 over to the right. That 5y would then become a negative 5y, and that negative 5 would then become a positive 5. So negative 2y minus 5y gives negative 7y. And negative 16 plus 5 will give me negative 11. So negative 7y equals negative 11. I take the negative 7 over to the other side. Since that negative 7 is multiplying by y, that means y is negative 11 divided by negative 7, which will give you 1 and 4 over 7, which is like about 1 comma, I believe it's 1,56 or 1,57. I believe it's closer to 1,57. I was doing this without a calculator. I call it pride. Anyway, 2 into x minus 3 equals 6 into x plus 4. Distributive law, break those brackets. So 2 multiplies into that bracket, turning it into 2 times x, which is 2x, minus 2 times 3, which is 6. And that equals 6 times x, 6x, 6 times positive 4, 24. I took the 6x over to the left, and I took the negative 6 over to the right. So I would end up with 2x minus 6x, and that equals 24 plus 6, which will give me negative 4x plus equals 30. And then x will then equal 30 divided by negative 4, which will give me essentially negative 7.5 or 7.5. Number 4. So number 4, it's another distributive law, but I just made it a little bit harder. So 3 into 2y minus 3 equals 5 into 2y plus 1. I got really uncreative with numbers, with coefficients. Anyway, so break the brackets, 3 multiplying into that 2y minus 3, granting us 6y minus 9. And that equals 5 into 2y plus 1, giving us 10y plus 5. I took the 10y over to the left, and that means I would bring the negative 9 over to the right. The 10 becomes negative 10y, and the negative 9 becomes positive 9. So 6y minus 10y gives me negative 4y. And the 5 plus 9 gives me 14. So y equals 14 divided by negative 4, which will give you negative 3.5. Do I have it? Yes. The next one, 6x squared minus 15 equals x squared plus 5. I brought the x squared over to the left, and I took the negative 15 over to the right. So that x squared becomes negative x squared, and that negative 15 becomes positive 15. 6x squared minus x squared, which is effectively 6 minus 1, which gives you 5x squared, equals 5 plus 15, which is 20. So 5x squared equals 20. Bring the 5 over first, because remember, multiplication before the exponent moves first. So divide both sides by 5. So x squared equals 20 divided by 5, which gives you 4. And then I moved it up here. And then you move the square sign over. The opposite of squaring is square rooting. So x is plus minus the square root of 4, which is plus minus 2. And then finally, I had 3y plus 20 equals negative y by itself. So if you got caught off guard with nothing else on the right hand side of the negative y, remember it doesn't, that's why there are rules in place. That's why there are guidelines. Get those variables with each other. It doesn't matter. It doesn't matter whether there's another number on the right hand side. Get that out. You don't want the variables and the numbers to be on the same side for now. So get that negative y over to the right and kick that 20 over to the other side. So you end up with 3y plus y, because negative y turns into positive y after going over an equal sign, and that positive 20 becomes a negative after going over an equal sign. That gives you 3y plus y, which is 4y equals negative 20. Then I take the 4 over to the other side, so therefore I have y equals negative 20 divided by 4, which gives me y equals negative 5. If you enjoyed this content, please leave a like. Please share with your friends and anyone else, and please subscribe and comment on what you want to see next, as well as any questions you have for me. With that being said, have a nice day.